All right. Good morning, folks. Welcome back. Um, just a quick note before we get started here. Uh, uh, at the rate we're going, I think we'll be done with this chapter by I think the end of next week. Next week, so just kind of keep that in mind, and then at that point, then we'll start talking about the exam for this chapter here. So just keep that in mind. Kind of looking forward. We're about a week away from that, but keep up with the work, folks. Make sure you come by and see me. Office hours are 1:30 to 2:30. If you have questions about the work that we're doing here, but I think we're working at a pretty good pace. In class today, in class here. Under the circumstances, we're doing a pretty good job of getting the work done. So come by and see me, folks. I know that the pace, I'm kind of pacing it at a rate that I think would be suitable for the circumstances that we are faced with here. But I do consider also then the things you guys have to worry about and do as well. So come by and see me. Let me know if I need to pick up the pace a little bit more or slow down the pace. But without that feedback, you guys, it's going to be I'm going to continue going the way that we're doing it now. So let me know how things are going for you guys. Let me know how these lectures are. The feedback's always useful for me. Feedback is always useful for me, whether even when we are together in class under normal circumstances. That feedback really helps me. Okay, so let me know how things are. Let me know how things are going here with the lectures, and then you can email me. You can meet me and let me know. But hopefully, then, like I said, this is a good pace. We'll try to get done with this chapter by next Friday. Okay, and then the following Monday we'll talk about the review process. And so the process will be very similar. I'll continue to make these announcements, and I'll remind you more as we get closer to that time. But just keep that in the back of your mind as we go through this. Okay. All right. What I'd like you to do here then is let's practice this problem. Okay. I told you yesterday that I'd like you to do more of these problems here where we're doing these mass-to-mass conversions. Okay. And so here's a problem. This is number 10 in your problem set. Let's work out these two conversions here. So these are two mass-to-mass conversions that I would like you to do. And then we'll work this out together. So take about 5 minutes to work out this problem here, and then set it up on your paper. Set it up, and then when you're done, let's get back. Let's unpause the video, and let's compare your answers to the work that we do here on together. Okay, so take about 5 minutes to get this done. And then we will work out this problem together. Your homework for tonight. Hopefully you were able to get set B done, folks. I think that's pretty straightforward. So there are other calculations in there we're going to go over. If you didn't quite get it done, go ahead and get it done and turn it in when you can. But come by and see me, folks. Come by and see me if you need any help with it. Okay, so let's get number 10 done here. Let's see how well you do, and then we'll get back together and we'll work out this problem together. Okay, go ahead and get it done. All right, let's go ahead then, and let's work this one out together. Okay, so this is stoichiometry, folks. Stoichiometry is the analysis of a chemical reaction to compare quantities in a chemical reaction. Okay, the quantities can be in terms of moles, it can be in terms of grams, mass, they can be in terms of volume, they can even be in terms of molecules and atoms, though typically we don't do that type of analysis because it's not really useful for us in order to carry out the reaction. So we do the analysis of the quantities. Quantities, remember, are amounts. So we are looking at a chemical reaction and we are analyzing it in terms of the amounts of reactants and products. Okay? That's stoichiometry. Stoichiometry is an analysis of quantities involved in a chemical reaction. And so the stoichiometry itself, the math that we have to do, is a pretty straightforward math. It's basically conversions that we have to do. We have to, and as a conversion problem, like I've been stressing this ever since we learned it back in chapter 3, as a conversion problem, you just have to basically ask yourself 3 questions. What am I given? What are you given to start out with? What is the starting quantity? What do they want us to solve for? What is the quantity that we want to end up with? And the conversion factors that will get us from start to finish. Okay, so with that said, then that's what you want to keep in mind as we move forward with this. And so let's go ahead and let's go ahead and get this done. Okay, so the very first thing you have to do when you when we do stoichiometry, remember always, is that you want to make sure you get the balance equation. So the problem here describes the reaction of ethene, acetylene, okay, burning in oxygen. So this is a combustion reaction. So write out the reaction itself. Okay, so well, let's write out the balance equation. So we start out with C2H2. This is acetylene, okay? And since it's a combustion reaction, we're going to burn it in oxygen, okay, to form then carbon dioxide and water here. Whoops, sorry. Okay, all right. At this point then, we'll get the balance equation. Make sure you balance everything out. So if you balance it out correctly, it should be 2, 5, 4, 2. 2, 5, 4, 2. Those are the coefficients of the balance equation. And stoichiometry always starts out with a balance equation because we need those coefficients, because those coefficients describe for us the quantities of reactants and products in this reaction. Now, on one level, we can use those numbers directly to obtain information about quantities. But on another level, especially the ones that we want to work with on the mass and volume level, we have to be able to calculate for it. Okay, so we did that early on in this chapter. You got to be able to do that as we move forward. Okay, but here what we're doing is we're focusing on quantities, okay, on stoichiometry. So next step, what you want to do then is write down what you are given and what you are solving for. So you can answer the first two questions by just labeling, just writing down what you were given underneath the balance equation. Okay, so we are told then that if how many grams of carbon dioxide and how many grams of water produced, so we're asked to find the amount of carbon dioxide and water produced if you start out with 52 grams. So we are given 52 grams of acetylene. Okay, so we're doing two different conversions here, folks. The first one, and I'm just going to say this. The first one, then we're going to find out the amount of the grams of carbon dioxide that that can be produced when we burn all the 52 grams of acetylene. And the second one is asking us if we have that same amount of acetylene, how much water will be produced when we use that. Okay. And so with that said, let's go ahead and let's do both of these conversions here. Okay, so hopefully you were able to get that done. Let's go ahead and let's carry out these two conversions. Okay, so what I'm going to do now then is, like I pointed out to you yesterday, and you won't, and I was telling you this as well. I'm not going to write out all of the mole ratios anymore. But if you have to practice doing that, go ahead and write out the mole ratios that you need. Okay, but at some point, hopefully, you'll be able to identify the mole ratios that you need. Okay, and obtain the molar masses that you need in order to do these conversions. Okay, so let's go ahead and do the first conversion here. Let's go ahead and do the first one. Okay, and so we start out then with 52 grams of C2H2, and we're going to find then the amount of carbon dioxide that will form. Okay, so remember, this is a mass to mass conversion. We start out with mass, we end up with mass. So it's masses of different compounds. We're doing a mass to mass conversion. As such, then remember we needed three conversion factors. We needed the molar mass of the starting compound. We needed the mole ratio between the starting compound and the compound that we want to solve for. And then we need the molar mass of the end compound. So essentially, if you can remember that, you don't have to write out all the mole ratios. You can just look for the compounds that are involved in this particular conversion here and use the coefficients for that. So let's go ahead and and I'll highlight that point again in just a moment. Okay? So with that said, then our first conversion factor, remember, then is going to be the molar mass of acetylene, C2H2. And we're going to divide by it. Okay, so which means then it's going to be 1 mole on top, C2H2, and 2 carbons, 2 hydrogens, going to give you a molar mass of 26 grams per mole. So we place 26 grams in the numerator here. Okay, and so that's our first conversion factor. Now, why do we use this? Again, because the grams of C2H2 cancels out. Okay, all right. The next conversion factor is the mole ratio. The mole ratio, remember, compares the moles of 2 two components of the reaction. What two components of the reaction do we want? What mole ratio do we want here? Well, we want the mole ratio for C2H2 when compared to CO2. And so we're going to use the mole ratio, the ratio between, I'm sorry, not that one, sorry, between C2H2 here and CO2 here, which means then we're going to use 2 and the 4. Now, how do we plug in that mole ratio? Well, let's go ahead and consider this, okay? So at this point here, we end up with moles of C2H2. We don't want moles of C2H2, and then we want grams of CO2. So can you imagine then the mole ratio that we're going to use? The mole ratio that we're going to use, and I'll write this here for you. The mole ratio that we're going to use here is going to be that it's going to compare 2 moles of C2H2 to 4 moles of CO2. So if you notice here, we didn't have to write out all the other ones. We just picked the 2 that are involved in this particular calculation, in this particular conversion. And it's C2H2 and CO2, and in a 2 to 4 mole ratio. So this is what we're going to use. Let's go ahead and plug it in then and use it. Okay. So we have moles of C2H2 here. We want that to cancel out, so we'll put moles of C2H2 on the bottom here. So this can be 2 moles of C2H2 on the bottom, 4 moles of CO2 on the top. And if we do that, the moles of C2H2 cancel out. And we're left here with moles of CO2, which means that we're almost to the finish, not quite, but we're almost to the finish. So you have to be able to obtain that mole ratio. So again, if you have to write out all of them, and there's going to be quite a few, and I would challenge you, and I would challenge you to do this, go ahead and write out all the mole ratios that you can obtain from this balanced equation. Okay? But if you are asked just to do this conversion here, you do not have to write out all the mole ratios. Just pick the one that you need. Okay? All right, very good. So with that said, then at this point in the conversion, we're not quite done yet because we have moles of carbon dioxide here. We need to get to the grams of carbon dioxide here. Then we're going to use the molar mass of CO2, and if that's 1 carbon and 2 oxygen, that's going to be 44. And so grams per mole, so we'll put 44 grams of CO2 on the top, 1 mole of CO2 on the bottom. Okay. And so if you plug in those numbers, okay, go ahead and plug in those numbers, okay, you should be able to get your answer as to 3 significant figures as being 176 grams of carbon dioxide, okay? All right, very good. So let's go ahead then and check your answers, check your work. Okay, and let's see if you get the same thing. Let's go ahead and do the second calculation here. Let's go ahead and do the second calculation. Okay, where again we start out with 52 grams of C2H2, and this time we want to find then the grams of H2O. So they're asking us to find then the mass of water that's going to be produced. Okay, all right. So first conversion factor again should be the same. The first conversion factor should be the same because we have the same compound to start out with. So we're going to use the molar mass of C2H2, and we will also again divide by the molar mass of C2H2. So that'll be 26 grams C2H2. Okay, so that should be the same. All right, now let's go ahead and let's ask this question here. What are the 2 compounds that we are comparing this time in this calculation? Okay, so let's go ahead and take a look at this. This time we are doing C2H2, yes, but this time it's water, H2O. So we will be looking at this right here and this right here. Okay, so that's what we're going to use. So it's going to be then 2 moles of C2H2 for every 2 moles of water. Okay, so that is what we need right there. Okay, again, we don't have to write out all the other mole ratios. We just need to find the mole ratio that involves the 2 compounds here that are involved in our calculation. Okay, all right, so how do we plug in that mole rate? How do we plug that in? So let's go ahead and plug it in. Okay, so if you notice here, we have moles of C2H2 here. So it'll be, we'll put that, 2 moles of C2H2 in the denominator here, and 2 moles of water on the top there. Okay, so that's how we would plug in this mole ratio here. And then so at this point here, then we'll need our last conversion factor, which is our molar mass here. This time it's going to be the molar mass of water, and that's going to be 2 hydrogens, 1 oxygen, which gives us 18 grams for every 1 mole of water. Okay, and you plug that in, and you'll get your answer then as being to 3 significant figures to the rounded to the nearest 10, 36 grams of water. Okay, all right. So this is the mass to mass conversion, folks. So make sure you practice this. So go back into the homework and practice this, because the process here, folks, is going to be exactly the same as you move forward. You're going to plug in different conversion factors, obviously, but the process is still the same. Where you're going to use the mole ratio, you're going to use one of the other conversion factors that we need, whether it's the molar volume or whether it's the Avogadro's number. You're going to plug it in that way, but it's going to be set up in exactly the same way. Okay, so take a look at that, folks, and make sure you get that done. And come by and see me, folks, if you have any questions on this. Okay, and that way then we will practice more of these problems together. Okay, so here we had a chance to do 2 different conversions. Okay, 2 different conversions involving masses. Okay? But we can do other conversions, folks. We can do other conversions based upon what we know about the relationship between the mole and, say, number of particles, or the mole and the volume of a gas. Okay, so I want to start out here then with this particular calculation here. Now, would we ever carry out this particular calculation in the laboratory? No. The reason then being is we can't measure out number of particles. We can't count that out. But what I want to point out to you here is that we want to practice these stoichiometric calculations because it's good practice for us. The mass-to-mass calculation, the volume-to-volume calculation, the mass-to-volume calculation, those are the ones that you would probably do in a science and laboratory setting, a chemistry laboratory setting. But it's good to practice what we're going to be doing here. Okay. All right. So with that said, then in this particular calculation, what we want to be able to do then is if we are given the mass of a given compound, one of the components of a chemical reaction, and we wanted to find the equivalent number of particles of another compound that either we need or that will form, we want to be able to do this calculation. If we want to be able to do this conversion here. And the question then is, can we do this conversion directly like we have here? No, we can't. Just like with the mass-to-mass conversion, we can't do this conversion directly. However, remember, back with the mass-to-mass conversion, we can carry out this conversion. That is possible because we have the mole ratio. And so with that said, then, the question then being then is, if we can find the moles of compound number 1, we should be able to eventually get to the particles of compound number 2. Okay, so this is a mass to particles conversion. So can we do this conversion here from mass of compound 1, the moles of compound 1? Can we do that conversion? Yes, we can, because we know the molar mass. So that would be exactly the same, this first step here. So this first step here will be exactly the same as the first step that we did. So step number 1 here in this conversion, okay, will be exactly the same as what we did with the mass-to-mass conversion. Step number 2 is also exactly the same as the mass-to-mass conversion. The only difference now is this last conversion, oh, excuse me, this last, hello, a little bit dust in my house, sorry folks. The only difference here is this last conversion here, okay? So the question then is, can we carry out this last conversion here? That is, once we obtain the moles of particle 2 here, the moles of compound 2 here, can we convert that to the particles of compound 2? And the answer is yes, because we know how to use Avogadro's number. And so this third step of the conversion here to get us from mass to particles, okay, a 3-step process, will be the use of Avogadro's number. Okay, so 3 steps again. To do this conversion, we need 3 steps: molar mass, mole ratio, and Avogadro's number this time, and we can get that conversion done. We can't do it in 1 step. We need to do it in 3 steps, and so make sure you keep that in mind. But we're not going to separate the 3 steps out. We're going to do it in one long conversion, and then get it done that way. Okay, so let's take a look at an example problem where we have to get that done. Folks, I would suggest you have these flow charts in front of you. If you need to, have them in front of you to help remind you how to do it. So this is kind of the map that you would use in order to get from this is the map of the conversion that you'd have to do. And so you just have to identify what you start out with, what you want to end up with, but I do list for you in this map the conversion factors that you need. Okay, so let's go ahead and let's take a look at an example problem and get this done. Okay, so here we have then our equation then again, our reaction again involving water, and this time it's a decomposition of water. So take a look at this problem, read it really quickly, okay? And let's go ahead and highlight what we have here. Okay? So we are told then we want to find then the number of molecules of oxygen. This is what we want to find. So that's what we're finding. What we were given then is the mass of water. Okay, so we're given the mass of water. We are asked to find then the number of oxygen molecules, number of particles that will form in this particular reaction. Okay, so that's what we have to identify. Let's go ahead then and let's work this problem out together. Okay. All right, so first thing we have to do, since this is a conversion problem, this is a stoichiometric calculation, we need the balance equation. Okay, so the balance equation for this one is a decomposition of water. So we start out with water decomposing into hydrogen. So make sure then that you get the formulas correct here. Remember, hydrogen and oxygen, diatomic molecules, so H2O2. The balance equation then is going to be 2, 2, 1 here. Okay, so always start out with the balance equation in order to get this done. Okay, next, write down what we were given. So we were given to start out with then that we have 29.2 grams of water, and we want to find then the number of oxygen, the amount of oxygen, but this time it's molecules of oxygen. That is molecules of O2. So that's the conversion that we want to do in this particular problem. Okay, so again, what I've done is I've answered the first question. What do we start out with? What do we want to end up with? And now and I've done it right here underneath the balance equation. So again, do it that way if you need to. Okay. And then what we're going to do is now we need to identify the conversion factors and solve for them. Okay, so let's go ahead and let's do that as well. Okay, so let's go ahead and work out what we have. Okay, so with that said, then we have. I'd like you to identify the molar mass. Okay, of water. So go ahead and write that down really quickly. Okay, I want you to identify the mole ratio. Okay, mole ratio that we'll need. Okay, and then so I want you to do this, and we'll work out this problem together tomorrow. I'm running out of time here. So what I'd like you to do to finish out today then is find then the molar mass, because we'll need that conversion factor. I want you to identify the mole ratio that we'll need, and then finally, what is the last conversion factor? What's the last conversion factor that we'll need in order to get this conversion done? Okay, so answer these 3 questions here. Calculate for the molar mass of water, identify the mole ratio that we need, and what is the last and final conversion factor that we need in order to get this conversion done. Okay, so please make sure you write that out on your paper. I'm not going to ask you to do the calculation yet, okay? But get those 3 questions answered, and then tomorrow we're going to start with this particular problem here. I'm going to use, I'm going to identify these. I'm going to answer these 3 questions for you, and then what we'll do then is we'll use them to start the calculation. Okay, all right. All right, so folks, make sure you come by and see me if you have any questions, and if you and get your questions answered. Okay. All right, folks, have a good day, and I will see you tomorrow.